Assalamualaikum dan hi guys. Okay, our group will present about our assignment PBL. So I will introduce my name. My name is Muhammad Afif bin Muhammad. Okay,
Okay, my name is Muhammad Saiti bin Muhammad Shukran.
My name is Ahmad Haris Behasri.
And for last, my name is Muhammad Zulhairi bin Aidi Jondi.
okay, that's all. Okay, enjoy. Okay, hi Sayuti.
Okay, hi
Alright,
Afif.
where's Zulkhairi and where's Ahmad? Yeah,
I think they are on the way to join our meeting.
okay, we have another 5 minutes.
Okay.
Okay, I will try to call them. Okay. Everybody's here? Zulkairi,
Yes, yes,
Ahmad?
yes. Yes, yes.
Yeah, I'm
Okay,
here.
just in time. Alright. Okay, so I conduct this meeting because I have some issues here right now. Alright, so I will present to you guys about the issue. Okay, can you see our yeah, our screen and my screen? Can you see?
Yes, yes, I see it.
All right. So we have an issues. So we as electrical engineer, and we have to ensure the stability and reliability of the power supply in rapidly growing urban area. Okay. So with the increasing population density and demand for the electricity, the existing electrical distribution system is facing the risk of overloading during peak periods. Okay, so we have to upgrade the plan to address this challenge and ensure the continued provision of uninterrupted electricity to the cities, residents, and businesses. And our plan is must comply with all applicable regulation, including the Electrical Supply Regulation 1990, the Electricity Supply Act 1994, and the Malaysian Standard MS issued by the Department of Standards Malaysia DSM. So as you can see, our issues is we have to plan some improvement, okay, some improvement to prevent from overloading lah to the growing urban area just now. Okay, so all right, so is anybody here have an idea about the how we can improve our distribution system? So anybody?
Uh, okay. Okay, Afif. My name is Saiti. I
All right.
think I have some ideas to upgrade for our problem.
Okay.
Okay, to solve our problem. So before I tell my ideas, let me introduce first about the distribution system. Okay, so let me share the slide. Okay, you see my slide?
Yes. Can
Okay,
proceed.
all right. Okay, Assalamualaikum. My name is Muhammad Saiti. Okay, now I want to explain first about the distribution system. Okay, this slide I present uh, distribution system. Okay, this is a PMU, and this is a PPU. This is a SSU, and then PE, and then to the consumer. Okay, Okay, so based on electricity regulation 1994, substation means any premise or enclosed part thereof which has a apparatus either from transforming or converting electricity to or from high voltage and or for the switching, control or regulation of electricity at high voltage and which is large enough to enable the person enter after apparatus is placed in that place and includes the apparatus therein interruption. Okay, based on the electricity supply application handbook, the definition of a substation is a facility where two or more lines are switched on for operational purpose, include one or more transformer, so that server connected lines operate at a different nominal voltage. Okay, generally, there are three categories of a substation for electricity supply distribution. As I say just a moment, first is we have a main incoming substation (PMU). It is pencawang masuk utama. And then the second is main distribution substation is PPU. Okay, pencawang pengagihan utama. And then the electrical substation pencawang elektrik PE. And however, there is an additional one substation categories for bulk user, which is the main switch substation. Station SSU is main station switch utama. Okay, now I want to describe for the what is PMU, what the function of PMU. Main incoming substation, it means power pencawang masuk utama. The main incoming substation PMU is a component in the electricity grid whose job is to convert the transmission voltage level either from high to low and low to high for the purpose of energy supply. Okay, this PMU accept the supply from transmission grids and PMU accept the voltage from transmission grids around 275 kilovolt or 132 kilovolt. Okay, next we move to the PPU, main distribution substation, pencawang pengagihan utama. The main distribution substation PPU is used on the 33 kilovolt system to connect the 33 kilovolt network with the 11 kV network. It injects capacity into the 11 kV network through a 33 or 11 kV transformations. Okay, in this distribution system, uh, the receiver voltage value of 33 kV will be lower to 11 kV for the main switch station. It's the SSU network. Okay, next we move to the next is SSU station switch utama. It's main switch station. Main switch station is the collection and installation of high voltage circuit breaker that are 33 kilovolts and 22 kilovolt or 11 kilovolt only without transformer created for the purpose of supplying large user, supplying ordinary user and strengthening the voltage network. Okay, now we move to the PE. PE is electrical substation pencawang elektrik. Okay, an electrical substation PE is a source station where the high voltage value of 33 kilovolt, 22 kilovolt or 11 kilovolt is reduced to 400 volt or 200 volt to supply the electricity to small and domestic consumer through overhead lines or voltage cable. Okay, the commonly used transformer capacity is 100 uh, kVA kilowatt hour kilowatt kVA and 300 kVA 500 kVA and then 750 kVA and 1000 kVA. Okay, the switching device used is a vacuum circuit breaker VCB and the switch gear is RMU. So my ideas from our problem, actually I have two ideas that tell I will tell my first idea is we can upgrade the power distribution system such as adding a new electrical substations. That's that PE. And then for the second ideas, we can upgrade the power distribution system at the electrical substation. Okay, that's all from me. Pass to Mama Afif.
Okay, so you have two ideas, right?
Yes.
And you seem you expert about the distribution system. Okay, nice.
Okay.
All right. So can you tell me the pros and cons about your two idea, all of your idea lah.
Okay. For my first idea is I create it for the long term. And then for my second idea, I just create for the short term. Why? Because our first idea we build a new PE, and then for the second idea, I suggest we change the component voltage divided is the component voltage divided. So there's a two uh um advantage and disadvantage lah. And the cost I think is the same, but my second opinion the cost is much expensive. All right. And but the weakness is the system is for short term. Okay, that's all for me.
So as you mentioned just now, there's your second idea is only for short term, right? Short term.
Yes.
Okay, so I think better you take the first idea only
Okay.
because your first idea is long term, right?
Yes.
Okay, so okay lah. So the second idea, we will remain for the first idea lah.
All right.
Okay, all right. So is anyone have another idea about our project development upgrade? Is anyone? Okay, Ahmad.
I think I don't have any idea, but I think that idea Sayati give is a good idea. But for next meeting, I will prefer for act and regulation for the ideas we can go on and clearly we can do it.
Okay, so how about Ahmad?
Okay. Tapi
Oh, okay lah. Just okay lah. Okay, alright. So Sayuti seems expert about the distribution system, is it? So, alright. So I think Sayuti can proceed to upgrade the distribution system.
Okay.
So I will assign Sayuti or do some research about upgrade for the distribution system lah. Okay.
Okay. Okay.
Okay. So as our assignment, as our issues right now, we have to upgrade and the plan and the planning must comply with the Malaysian Electrical Act. So I will assign Zulkhairi to do some research about the Malaysian Electrical Act. Okay, Zulkhairi. All right.
Okay.
And okay, so Ahmad Haris. So okay, so you can do some research about additional features idea planning lah. Okay,
Okay,
you
Afiq.
can do some research. Okay, for the additional idea lah to upgrade from prevent to overload. Okay, so
InsyaAllah.
okay, Alhamdulillah. All right. So Zulkairi make sure you assist Sayuti and Ahmad Aris based on their ideas. So you will assist them to comply with the all Malaysian Act lah. Okay.
Okay. Okay. I can.
All right. Okay. So I think that's all from. I think we can end our meeting. Okay, so make sure all of you prepared and stand by your ideas in the next meeting. Yeah. Okay, so that's all. I think we can end our meeting. Yeah. All right. Okay. Thank you for joining. Okay. See you guys in the next meeting.
Okay. Thank
Okay,
you.
thank
Okay.
you.
Thank you.
All right. Okay. Okay. Okay.
See you.
Okay. Bye. Okay. So okay, can continue. All right. So basically, in the last meeting, I have assigned you guys each task. Lah. So, Sayuti, have you prepared your ideas about the distribution system?
Yes. I have already prepared uh for all my ideas. Okay.
Right. So, Zulkhairi, so have you researched about our Malaysian Act?
Yeah. Yeah. Yeah.
Okay. So I think Zulkhairi can brief some general explanation about our Electricity Malaysian Act. Okay.
Okay.
Are you ready?
So I'm ready. Then I share my slide.
Okay. Thank you.
Okay. So okay. Firstly, we go to project overview. This project is developing a comprehensive upgrade plan for electrical distribution system to address overloading during peak period involve careful consideration of the various factor. Here is a step-by-step plan that take into account the relevant act and regulation. This recommendation including the Electricity Supply Regulation 1990, Electricity Supply Act 1994, and the Malaysian Standard MS issued by Department of Standard Malaysia. So we go to the General Act and Regulation. So next slide. Regulatory compliance assessment begin by conducting a thorough assessment of the existing electrical distribution system to identify area potential overloading and non-compliance with the Electricity Supply Regulation 1990 and the Electricity Supply Act 1994. So the ensure that the upgrade plan align with the regulate requirement and any proposed change adhere to the specific standard. So the general for the regulation and act electricity act 1990 is at the section 9 lesson requirement for use of installation, terms, condition, and the content of lessons. For latest regulation 1994 is a regulation 110 inspection and the test for the purpose of the maintenance of installation. So that's all about general electrical supply and regulation for this project. So I will pass to Afif to continue this for ni to sambung.
Okay.
Okay, sambung.
All right. Thank you, Zulkhairi, for the general explanation about Malaysian Act. Okay. So I hope you guys understand. Okay, so I think Sayuti, are you ready for your explanation about the distribution system upgrade planning?
Yes, I'm ready for to explain about
Okay, so
my.
you can proceed.
Okay, let me share my slide first. Okay. Do you see my slide?
Okay, yes.
All right. Oh, okay. All right. Assalamualaikum. Okay. Today I want to present my planning. What I need. What I want to upgrade. For my ideas. Okay. This is I designed to the this distribution system for PE. KPE is power pencawang elektrik. Okay. So I plan to separate electrical substation PE for residential areas. Okay, residential areas and industrial industrial areas. Okay, by making a plan for the additional of electrical substation PE. Okay, so for the electrical substation PE for residential areas, as you can see, for the electrical substation PE in residential, I suggest we use the switchgear distribution system. Is the RMU. Why? Because RMU are primarily used in the distribution network to control and protect the flow of electrical power. They are commonly employed in ring main system where power is distributed to multiply branches. Okay, RMU are typically used the low to medium voltage applications, ranging from a few kilovolt up to around 36 kilovolt something. And then the RMU is generally have a lower breaking capacities compared to BCB, vacuum circuit breaker. They are suitable for interrupting smaller fault current typical encounter in distribution network. And then the RMU may use different arc interruption media, such as air, SF6, hexafluoride, hexafluoride gas, or vacuum. Okay, and then depending on the specific design and applications. So SF6 gas is commonly used in RMU for its excellent insulting and arc quenching properties. Okay, the RMU are equipped with a load break switch. Okay, which allow for the interruption of the current flow under the normal operation conditions. Okay, this feature is useful for a selecting section of the distribution network for the maintenance or repair purpose, and then without disrupting the entire system. Okay, the RMUs also offer the flexibility in terms of configurations and expandability. They can be easily expanded by adding more modules or units, allowing for future system modification or extensions. And then for the cost, switchgear, generally have a lower upfront cost compared to VCB, virtual circuit breaker. They are more economically viable for low to medium voltage distribution system due to their compact design and simpler constructions. Okay, now we move to the industry distribution system that I designed. Okay, for the electrical substation PE for industrial areas. Okay, I suggest that we use a vacuum circuit breaker VCB distribution system. Why? Because VCB are used for high voltage applications and such as the transmission network and large power plants. And then they are designed to interrupt the flow of current in case of fault of overload conditions. And then VCB are designed for high voltage applications and can handle the voltage ranging from medium voltage. Example from the 11 kV up to extra high voltage until 400 kV. So it is suitable for industry sections. Okay, then VCB is that vacuum circuit breaker also have higher braking capacities and can interrupt large fault currents. And VCB can making them suitable for high voltage transmission system. Okay, so VCB are primarily circuit breakers designed to interrupt fault currents, while they can be used for load breaking. And then in current applications, their main function is to protect the system from faults and overloads. Okay, and then BCB are generally standalone circuit breaker and do not offer the same level of modular expandability as RMU, as that switchgear. However, they can be integrated into large switchgear agreements or panel boards to meet the specific system requirements. Okay, for the cost, BCB is tend to have a higher initial cost due the more sophisticated design, large braking capacities, and high voltage capabilities. Also, however, the long-term operating costs, including maintenance and replacement, can vary based on specific factors such as the fault rate and system requirements. So, that's all from me. Fifth.
Okay. So PCB is vacuum circuit breaker, is it?
Yes. BCB is a
Okay.
vacuum circuit breaker.
Okay. So is you mentioned about ring main system, right?
Yes.
So as for your information,
Okay.
ring main system is primary of distribution transformers form a loop, and the loop circuit start from the substation bus bar and make a loop through the area to be served and return to the substation. Is it correct?
Yes. Is it correct? Yes,
All
that's
right.
correct.
Okay. Thank you for your ideas, Ayuti. Okay. So, mm, so our PBL is must comply with our issues. It must comply with the Malaysian Act as so Zul Khairi. Okay, so as and the Sayuti's idea based on your research, is that all the Sayuti's idea comply with the All Malaysian Act?
Okay. Thank you to Saiti for give the idea. That it was a great idea. So I just want remind you about the regulation and act for this project. So we go to my slide. I share my slide. Okay. Ensure that the upgrade plan that was Sayuti said align with the regulation requirement and any purpose. Change the adhere to the specific standard. So for the first, we go to Electric Supply Act 1990. In Section 9, for this project, Section 9, lesson required to use of the installation, terms, condition, and content of lesson. So we can see for this project, RMU is you want to up to around 36 kilovolts. So that is a high voltage. So for the lesson and requirement for this project, we need to somebody have certified for this project to go on. That's our cable. So we need to judgment that PO. We need to helper in judgment two as A4, A1. So we go next. So the Sayuti, do you have said that you need to for the first before I forget, we go to uh egg supply section 9. I said we have in subsection number 1, that's mean tertakluk kepada apa-apa pengecualian yang diberikan di bawah akta ini ditetapkan tiada seorang pun selain pihak berkuasa bekalan, iaitu subsection A mengerjakan atau mengendalikan atau membenarkan diguna, dikerja atau dikendalikan apa-apa pemasangan, atau subsection B membekalkan elektrik daripada mana-mana pemasangan atau bagi kegunaan mana-mana orang lain kecuali di bawah dan mengikut terma dan syarat sesuatu lesen sebagaimana yang ditetapkan yang membenarkan pembekal atau pengguna itu mengikut mana-mana yang berkenaan. So for this project, we need to get our person that have a certified for this project. Like I give you example that Sayuti said 36 kilovolt. So that is a high voltage. We need a judgment BO or B4 for handle that's supply. And yes, we have need to the helper that have a certified judgment too, but I think F4 can and BO can. So we go to next for the idea from Sayuti. They had say he wants to upgrade our PE, pencawang electric. So they have to need to dia perlu memasuki tanah dengan pembinaan. So ia tertakluk kepada section 11, di mana section 11 mengatakan kuasa untuk memasuki tanah bagi memasuki pembinaan ataupun projek. So subsection pertama tertakluk sebagai yang diperuntuk. Kemudian daripada ini, bila masa perlu buat demikian bagi maksud memasang apa-apa sistem pengagihan elektrik di bawah akta ini. Pemegang lesen, that means that person have a certified for electrical, memasang apa-apa sistem pengagihan elektrik, membawa di atas, di bawah atau melewati mana-mana tanah selain tanah negeri, apa-apa tiang dan kelengkapan lain yang perlu atau wajar bagi maksud pemasangan berlesen mengikut mana-mana yang berkenaan dan boleh mengambil apa-apa tindakan lain yang perlu untuk menjadikan pemasangan itu selamat dan cekap. Membayar pampasan penuh mengikut Seksyen 16 kepada semua orang berkepentingan kerana apa-apa gangguan, kerosakan, ketidakupayaan yang mungkin disebabkan olehnya, dan pampasan itu boleh termasuk bayaran tahunan bagi tanah yang digunakan. So kat sini kita boleh bayangkan, contoh kalau kita masuk tanah tu, mungkin kita kena bayar sewa tahunan kepada tuan tanah. Okey. Subsection nombor 2, ini adalah peraturan penting sebelum kita masuk, iaitu sebelum memasuki mana-mana tanah bagi maksud yang dinyatakan dalam subsection 1, pemegang lesen hendaklah memberi notis yang menyatakan dengan sepenuhnya dan setepatnya yang mungkin jenis dan takar tindakan yang dicadangkan hendak dilakukan. Notis ini hendaklah pada sebahagian besar dalam bentuk yang dinyatakan dalam jadual pertama, dan pentadbir tanah daerah hendaklah menyatakan tarikh pihak berkuasa negeri akan menyiasat apa-apa bantahan yang mungkin telah dibuat sebagai mana yang diperuntukkan kemudian daripada ini. Okay, that's all for me for that act and regulation. So I hope that act and regulation we can follow it, and for we can follow it, that's necessary for us to avoid being fined than accident that's we don't what to happen. So I pass to back to Afif.
Okay, thank you, Lucky. About the Malaysian Act. So, alright. So basically, Sayuti's ideas is aligned with the Malaysian Electricity Act, is it? Khairi? Okay, so thank
Yes.
you. I think we can proceed with the Sayuti's idea for improving our distribution system to prevent from the overloading. Okay. Okay. So I think that's all from this meeting because I have no time after this. I have some I have something lah after this. Okay. I think we can proceed for the next meeting lah. Okay. So alright. So settle. We proceed with the this idea. Okay. Before we end our meeting, Ahmad, you can prepare for the additional features, agreed planning for the next meeting. Yeah. So
Okay, Habib.
okay. So make sure for the next meeting you will present about your ideas. Okay. And Zulkairi, you make sure you will assist the Ahmad for the idea and for the Malaysian Act electricity lah. Okay. All right.
Okay.
So I think that's all from me. Thank you for joining the meeting. Okay. So see you in our next meeting. Okay. Thank you.
Okay, thank you.
Thank you.
So we continue on our final last meeting. Yeah. Okay. So everyone's good. Okay.
Yes.
Yes, we good.
Okay. So how's your holiday, Ahmad? How's your holiday last week? Ahmad, or you don't hear?
Yeah, I hear that.
Oh, so how's your holiday?
Hmm.
You went to Bali, right?
So
Last week.
so
Oh,
lah.
Oh. Okay lah. Okay. So I think we can proceed with our funny meeting lah. Okay. So based on the last meeting, Sayuti has proposed the ideas about I think separate PE pencawang electric. Is that correct, Sayuti? Okay.
Yes, yes.
Okay, so separate PE, one for the resident, one for the industry. Okay. Okay, so and the idea is all with, is comply with the Malaysian Act electricity. Okay, so now focus to Ahmad Ahmad's idea about the additional features project upgrade. Okay, so are you ready, Ahmad?
Yes, Afif.
Okay, so if you're ready, you can proceed. You can continue.
So I start now, yeah?
Okay, sure, sure, sure.
Okay. Before I start, I will share my slide. Okay. Bismillahirrahmanirrahim. For my additional features, to address the challenge of overloading in the electrical distribution system in the rapidly growing urban area, the following comprehensive upgrade plan is proposed to first load analysis and system assessment. Analysis and system assessment. First, conduct a detailed load analysis to identify peak demand periods and location. Second, perform a comprehensive assessment of the existing electrical distribution system to identify weak points and potential areas of overloading. To propose the goal of load analysis is to understand the electricity consumption patterns, peak demand periods, and locations with the highest demands. This information is crucial for designing a distribution system that can handle the varying load effectively. The step is collect historical data on electricity consumption, including daily and seasonal variation. Analyze trends to identify peak demand periods, which could be daily, monthly, or seasonal. Use load forecasting techniques to predict future demand growth based on factors such as population growth, economic development, and urban expansion. Categorize different types of loads such as residential, commercial, and industrial to tailor solutions for each category. Next, capacity upgrade. Capacity upgrade first increase the capacity of transformers, substations, and other key components in the distribution system to accommodate the growing demand. Second, implement smart grid technologies for better load management and distribution efficiency. To propose increasing the capacity of key components in the distribution system is essential to accommodate the growing demand for electricity in a urban area. This involves enhancing the capability of transformers, substation, and other critical infrastructure to handle higher load. Step. First, smart grid technologies. Purpose of smart grid implementation: integrate smart grid technologies to optimize the performance of the distribution system. Implement advanced metering infrastructure AMI to enable real-time monitoring of energy consumption and demand patterns. Utilize smart sensors and communication device for remote monitoring and control of key assets. Benefit of smart grids. Enable demand response program to encourage consumer to shift energy consumption to non-peak hours. Facilitate predictive maintenance by providing real-time data on the health and performance of critical components. Enhance grid resilience and responsiveness through automated fault detection and isolation. Next, voltage regulation. Voltage regulation. First, implement automatic voltage regulation systems to maintain stable voltage level within the permissible limits. Second, upgrade and install voltage regulators at critical points in the distribution network. The purpose is voltage regulation is crucial for maintaining stable and within permissible voltage level throughout the distribution network. Fluctuation in voltage can lead to equipment damage, efficient operation of appliance, and overall instability. Implementing effective voltage regulation measure is essential to ensure the quality and reliability of the power supply. Step. First, upgrade voltage regulator. Evaluate exciting regulator. Assess the performance of existing voltage regulators to ensure they meet current standards and are capable of handling the anticipate load variation. Replace or upgrade outdated or inefficient voltage regulators to improve reliability. Second, monitoring and control. Implement real-time monitoring. Integrate real-time monitoring systems to continuously track voltage levels across the distribution network. Utilize smart grid technologies to gather data and identify areas with voltage deviation. Next, renewable energy integration. First, explore the integration of renewable energy sources such as solar and wind power to diversify the energy mix and reduce dependency on traditional source. Second, implement energy storage solution to store excess energy during peak periods for use during peak demand. The purpose is integrating renewable energy source into the distribution system is a sustainable approach to meet the increasing electricity demand while reducing environmental impact. This step involves incorporating sources such as solar and wind power into the energy mix. Step first, feasibility studies. Identify suitable location. Conduct feasibility studies to identify location within the urban area suitable for renewable energy installation, considering factors like solar exposure and wind pattern. Wind patterns. Assess the potential capacity of renewable energy source in those locations. Second, solar power integration. Install solar photovoltaic PV system. Implement solar PV system on rooftop of residential, commercial, and industrial building. Install solar farm in open areas with high solar exposure, contributing to the overall energy generation capacity. Smart inverter and storage. Utilize smart inverters to maximize energy production and efficiency. Implement energy storage solutions such as batteries to store excess solar energy during periods of low demand for use during peak periods or cloudy days. Next, emergency preparedness. First, develop and implement contingency plans for emergency situations, including temporary load shedding measures and alternative power source. Second, train personnel and conduct regular drill to ensure a rapid and an effective response to any unforeseen events. The purpose is establishing robust emergency preparedness measures is crucial to mitigate the impact of unforeseen events, ensuring the continuity of power supply and safeguarding the well-being of residents and business. Step first, risk assessment and identification. Conduct comprehensive risk assessment. Identify potential risks and vulnerabilities in the distribution system through a comprehensive risk assessment. Consider natural disaster, equipment failures, cyber threats, and other factors that could lead to emergencies. Second, alternative power source. Identify and deploy backup power. Identify critical facilities and infrastructure that require continuous power supply during emergencies. Install backup power source such as generators or energy storage system to ensure the availability of electricity during outage. Last, regular maintenance and upkeep. First, establish a robust maintenance schedule for all equipment and infrastructure to prevent breakdowns and ensure the reliability of the distribution system. Second, regularly inspect and upgrade aging components to maintain high performance standards. The purpose is regular maintenance and upkeep are crucial aspects of ensuring the long-term reliability and efficiency of the electrical distribution system. Here, how this activity can be integrated into the comprehensive upgrade plan. Step first, regular inspection. Schedule inspection. Conduct the regular inspection of substation, transformers, and other key infrastructure components. Establish a routine schedule for visual inspection, thermographic survey, and others diagnostic tests to detect signs of wear, corrosion, or overheating. Second, maintenance. Preventing maintenance is implement a preventive maintenance schedule for all equipment based on manufacturer recommendation and industry best practice. Prioritize tasks such as cleaning, lubrication, and tightening connections to prevent equipment degradation. Okay. By implementing this comprehensive upgrade plan, the power utility company can enhance the capacity, efficiency, and reliability of the electrical distribution system while ensuring compliance with regulation and promoting sustainable energy practice. Okay, that's all from me. Thank you.
All right. Okay, great idea, Ahmad. Thank you. Thank you for the presentation. Okay, so there's a lot of idea, yeah, Ahmad, yeah. Okay, so good job, good job. All right. So Zulkhairi, based on the Ahmad's idea, is that all the ideas is comply with the Electricity Malaysian Act? Do you have some comment about it?
Okay, thank you to Ahmad. Is a good ideas. They have uh what I take a note from ideas Ahmad. They have six point that try to keep the idea to success to keep success this project. So first is load analysis and system assessment, capacity upgrade, voltage regulation, renewable energy integration, emergency preparedness, and for the lastly is regular maintenance and upkeep. That's true, Ahmad.
Yes, Zulkhairi.
Okay, so For I matching for uh, regulation 1994. Uh, the first is about first is about a grid. A smart grid purpose is smart grid implementation, and for the upgrade voltage regulate for the section that will be same like SAYUT, same section number 9, subsection number 1 and 2. So for addition, in regulation, we can take that point to regulation number 24, subsection number 1, number 2, number 3, number 4, and number 5. That's be number 1. Suatu kabel fleksibel bagi radas mudah alih hendaklah disambungkan kepada sistem dengan cantuman kekal atau palam dan soket yang dibina dengan sempurna. Subsection number 2. Suatu radas mudah alih dan kekal fleksibelnya hendaklah dikawal dengan cara yang berkesan, yang diletakkan pada tempat yang sesuai dan berpunya mematikan radas. Subsection number 3. Suatu bahagian logam radas mudah alih yang terdedah hendaklah dibumikan secara berasingan dan mana-mana penutup logam konduktor hendaklah dibumikan. And number 4, suatu radas mudah alih yang terdedah pada cuaca atau yang boleh dicapai oleh mana-mana orang biasa bekerja berhampiran dengan lantai berkonduksi hendaklah dibina daripada penebat sepenuhnya atau dibumikan. So that's my first point for ideas Ahmad. We go to number 2. That's have a renewable energy integration. So for that Ahmad point, what I understand is about installer solar photovoltaic system. Is this true?
Yes, install solar.
Okay, for the solar, I don't have anything talk about solar, but for the solar, because solar is a open project. They have nothing to keep that solar being stay safe, because solar is one need to from a sun, so it will be an open project. So for that, I think that we can be take regulation 34, that uh, in 34 we said pembumian bahagian logam, point neutral dan sebagainya. And I think regulation 35, that means how to kaedah pembumian. In that case, for 35, dalam mana-mana pemasangan sistem pembumian, konduktor yang lengkap yang dibuat daripada bahan yang boleh diterima dan mempunyai luas keratan rentas yang mencukupi dengan satu atau lebih plat bumi, pipe ataupun rod hendaklah diadakan. Sistem membumi itu hendaklah ke bumi dan disenggara dengan berkesan. So that means this is a safety for solar project that we will include in this project to upgrade that voltage and upgrade the electricity for human at the city. So I
Just
think that's
just safety information lah.
yes.
Uh,
So and lastly, for idea from Ahmad, that says regular maintain and upkeep. So that means you need to someone to stay and regular maintain to keep that our project, it will be good for long term. So in regulation, so we can take one regulation for that point. That means in 110, let's say pemeriksaan dan ujian bagi maksud penyelenggaraan dan pemasangan. Okay. For subsection 1, sesuatu pemasangan hendaklah disenggara dalam keadaan baik, berfungsi dan langkah-langkah awasan hendaklah dipatuhi pada setiap masa untuk mencegah bahaya. For number 2, tanggungjawab untuk menyelenggara pemasangan mengikut cara yang dikehendaki dalam sub peraturan 1 hendaklah terletak pada pemunya, pengurusan atau pemegang lesen atau penghuni pemasangan, perkhidmatan atau engineer mengikut mana-mana yang berkenaan. So this subsection 2 that say our project we need to certify from person that have lesen like BO before. So we can take this idea perfectly. And this idea is for long term. So I think this is a good for this project. That was my comment to idea from Ahmad. That was a great idea.
Okay, so do you mean the Ahmad's idea is comply with the all electricity Malaysian Act? Is that correct? Zulkhairi?
Yes.
Okay, all right. So thank you. Thank you to Ahmad and thank you to Zulkhairi about the presentation and about the
Okay.
comment.
Thank you.
So I think we have all the point and we have all the ideas how to improve our distribution system to prevent from overloading. Right? Okay, just a moment. Okay. Okay, so I will recap. I will do some recap for the first meeting until the last meeting. Okay. Based on the Sayuti's idea, Sayuti proposed about the additional PE pencawang electric. Is that correct?
Yes, yes, Afif.
Okay, thank you. Right, so that's the Sayuti's idea for the main distribution system. Alright, so for the Ahmad's idea, you have 6 points, 6 ideas about the planning, right? Okay, so the
Yes,
first
Afif.
one, load analysis, capacity upgrade, voltage regulation, renewable energy integration, emergency preparedness, and regular maintenance and upkeep. Okay, so you mentioned about capacity upgrade, is it? The
Yeah.
smart grid technology. I really interested with the smart grid technology. Okay, just for your information, I actually do some the smart grid technologies research before that. Okay, so the smart grid technology is an electricity network that use digital and other advanced technologies to monitor and manage the transport of electricity from all generations sources to meet the varying electricity demands of end user. And we also can monitor using the real time monitor using this smart grid technology. So I really interested with this idea,
Okay, thank you, Afif.
right? So I think we can proceed with all the ideas and yeah, just make sure our ideas comply with the electricity Malaysian Act and they will assist by the Zulkhairi. Okay, so that's all. I think that's all of from this our meeting. Okay, so okay, thank you to all, Sayuti, Ahmad, and Zulkari about the ideas. Sayuti for the distribution system, Ahmad for the additional features, upgrade planning, and Zulkhairi about the Malaysian Electricity Act. Okay, so all right. So thank you. I will end this meeting right now. So
Okay.
until we meet again.
Okay.
Okay, thank you.
Okay, thank you.